Configuration files come in 3 dominant flavors, and picking the right one matters. TOML powers Cargo.toml and pyproject.toml. YAML drives Kubernetes manifests and Ansible playbooks, and JSON rules package.json and REST APIs. On readability, TOML stays clean and flat with simple key equals value pairs. YAML leans on indentation and colons, which reads naturally but breaks if a single space is wrong. JSON wraps everything in braces and demands quotes on every string. Comments are where JSON immediately loses points. TOML uses the hash symbol for comments, YAML uses the same hash, and JSON officially has no comment syntax at all, which is why you will sometimes see hacky_comment keys scattered through JSON files. Data types separate the 3 formats significantly. TOML supports strings, integers, floats, booleans, arrays, and tables natively, with each type declared explicitly. YAML auto-detects types, which sounds convenient until the Norway problem bites you. Country. And no silently parses as the boolean false. Quoting is another minefield. JSON requires double quotes on every string and forbids trailing commas, full stop. YAML's flexible quoting means values like yes, no, on, off, true, and false get auto-coerced into booleans unless you wrap them in quotes, and numeric-looking strings face the same trap. TOML only requires quotes for strings, leaving numbers and booleans unquoted, so there is no ambiguity. So here is the rule of thumb. Use TOML for application configuration where clarity and explicit types matter. Use YAML for orchestration tooling where humans edit large manifests frequently. Use JSON for the wire, for APIs, and anywhere machines exchange structured data. We'll parse a small TOML file with Python's built-in tomllib module, and a JSON file with the JSON module. Then inspect the resulting Python objects. The goal is to show that TOML maps cleanly to native Python types. Strings stay strings, arrays stay lists, integers stay integers. First, we clear the screen to start with a clean workspace, then create a TOML file with 2 keys. A string called title and an array of integers called nums. We verify what we wrote by catting the file. Both lines are present. The title key and the nums array, exactly as TOML syntax expects, a bare key, an equals sign, and a value. Now we hand the file to Python's tomllib module. We open the file in binary mode, tomllib requires that, and load it directly. The printed result is a Python dict with the string demo, and the list 1, 2, 3, as native types. Notice what just happened. toml's demo came back as a real Python string, and the array came back as a real Python list of ints. No manual parsing, no string splitting, no type coercion. The TOML spec already mirrors Python's data model, so tomllib returns objects you can use immediately. For comparison, we load a JSON file the same way. Open json.load print. JSON parses into a dict just like TOML did, but JSON only knows objects, arrays, strings, numbers, booleans, and null. There's no concept of a bare string scalar at the top level, no dates, no inline tables with the same ergonomic feel. Both parsers return a dict that prints identically, but the round-trip behavior differs. A toml file written by hand can be loaded, modified, and with tomllib sibling tomly_w or tomly_ws modern replacement, written back without losing types. JSON is fine for data interchange, but TOML is designed so its types map 1:1 onto Python, which is why config files like pyproject.toml work so naturally. TOML is your go-to for per-project configuration files that a developer reads and edits daily. It hit its 1.0 stable spec in early 2024, and the format is deliberately unambiguous. A table is always a table, with zero room for misinterpretation. It supports comments, which JSON famously does not, and the key value syntax feels instantly familiar. That's why Cargo.toml and pyproject.toml both standardized on it. YAML wins the moment you need large, expressive, nested structures that a human reviews occasionally but rarely hand edits line by line. Think Kubernetes deployments and Ansible playbooks, files that describe a desired state for an orchestrator to enforce. The whitespace-based syntax reads almost like documentation, and the indentation makes hierarchies visually obvious. Rust, Go, and Python all ship parsers, so the tooling story is solid. JSON is the lingua franca of the wire. Every programming language has a parser, the syntax is strict, and there's zero ambiguity in what a given byte sequence means. That's exactly why it dominates REST APIs, package manifests that other tools consume, and any place a machine hands structured data to another machine. Comments aren't allowed, and honestly, they don't need to be. The producing service is the documentation. Here's the decision flowchart that ties it all together. First question. Is this data crossing a network or being written by a machine? Use JSON. Second. Is this a large declarative orchestration file that humans edit occasionally? Use YAML. Third. Is this a per-project config file that a developer reads and edits daily? Use toml. 3 questions, 3 answers. Let the audience and frequency of edits decide. Right tool, right job. toml for the files you live in, YAML for the files you describe state to, JSON for the files that travel. Let the audience and the frequency of edits make the decision for you.